Hello, this video is going to cover some solving equation techniques, okay? So 3x squared minus 27. There is no variable here. I have two terms, so I'm thinking, well, can I factor that? Well, yes, sure, I can factor. I have at least a factor of 3 here and here. So if I factor out a 3, I will be left with x squared, right? Factoring out is a division, so you divide that by 3 and that by 3. So you're left with x squared minus 9. And at this point, I'm looking at this and I say, oh, that's a difference of perfect square, so that could be factored one more time. So it will be 3, and we're going to end up with the conjugates here, x plus 3, x minus 3. Those are what we call the conjugates, right? They have the same thing inside, except they're separated with an addition and a subtraction. Once this is set, I'm going to set it equal to 0. That was a typo. That shouldn't have been 0 at the first place. So we're going to set that equal to 0. We now have a zero product property. So when we multiply things and we get a 0, we know that any of those factors could be 0. Well, 3 cannot be 0, right? Obviously, 3 is 3. So we know that's not going to be 0. But this one could be 0. So that when we multiply, we get a 0 at the end. Or this one could be 0. So what would those x's have to be to make those go to 0? Well, if you subtract 3 here, x will be equal... Oh, I said 3 and I write 3 instead of x. When you subtract 3, x will become negative 3. So if x will be negative 3, that would all go to 0, right? Because that will become a 0. Anything times 0 is 0. And here x minus 3 equals 0. That means x will be equal to a positive 3. So those are the two solutions we have for number 1. And we got that by factoring. Then number 2, again, I'm looking, that's a quadratic. It's a trinomial now, so I'm looking for a different technique, and hopefully factoring will be good. So I have to ask myself, what can I multiply to give me a negative 11 and add up to give me a negative 6? Multiply to give me negative 11, add up to give me a negative 6. Well, multiply to give me an 11 would just be 1 times 11, right? I don't have an option there. And that would never add up to a negative 6. So there is no way I can factor that. Well, if it's not factorable, I have other options, right? I could do the quadratic formula, or I could do a completing the square. So how about checking a completing the square? Completing the square, you need the leading coefficient to be 1. That's already the case. We have a 1 there in the front. Then you're going to look at your linear term, which is the coefficient of the x to the first power. So you're going to take that linear coefficient, you're going to divide it by 2, and you're going to square that value. So negative 6 divided by 2 is negative 3. Square that value becomes a positive 9. So what that's going to become is x squared minus 6x. So I haven't changed anything here. But instead of that negative 11 here, I want a 9. So I'm going to add 9 here. I'm going to take that negative 11 and I'm going to add it to both sides of the equal sign so that it will cancel here and become a positive 11 on that side. And because I changed my equation by adding a 9, I'm going to also add a 9 on the other side of equal sign so that I don't change my equality, okay? Why did I want to do that? Because now this here factors very nicely. It is now a perfect square trinomial, so it becomes x minus 3 quantity squared. And if you don't believe me, just do x minus 3 times x minus 3, and you should get that x squared minus 6x plus 9 back, right? And then this is 11 plus 9, which is 18. And remember, our goal is to get x by itself, so once we have that like that, we are now going to take a square root on both sides. And so I have x minus 3, because the square root and the square are inverse operations, they cancel each other. And here, the square root of 18. So on the side here, let's remind us that 18 is the same thing as 9 times 2, and we're in a square root, so we needed a perfect square. 9 is a perfect square, so it comes out of the square root as a 3. And the 2 is not a perfect square, so it stays in the square root. So the square root of 18 becomes a 3 times the square root of 2. So 3 square root of 2. And it becomes a plus and a minus. And now we just have to add 3 to both sides, and the final answer becomes x is equal to, when I'm adding 3, that becomes a positive 3, and then plus or minus 3 square root of 2. And that will be our answer here. Alright, number 3. So we have a 3x squared minus 6x minus 1. Is there any way we could factor that? Well, 3 times negative 1 will be negative 3. Is there anything I can multiply to give me negative 3, but add up to give me a negative 6? Well, to multiply to give you a 3, you need a 1 and a 3. That will not add up to give you a 6, so you cannot factor. So we could complete the square again, or since we already completed the square, we can do a quadratic formula. So how about a quadratic formula? For the quadratic formula, we need a, b, and c. A is always the coefficient in front of your quadratic term, so in front of x squared, so that will be a 3. B is always the coefficient in front of your linear term, in front of the x to the first power, that will be negative 6. And c is always the constant, the number that doesn't have a variable. And then the quadratic formula itself is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so once we have all of that established, let's go ahead and set up our quadratic formula. So that will be x is equal to a negative b, and b is a negative number, so we have a negative 6 plus or minus the square root of b squared, so b is a negative 6, so put that in your parentheses and then square on the outside, and then minus 4 times a, which is 3, times c, which is a negative 1. Make sure your square root goes all the way to the end, all over 2 times a, and a is 3. Okay, we want to do the discriminant first. The discriminant is whatever is underneath your radical here. So negative negative becomes positive 6 plus or minus square root of 6 squared is 36. Let's write that on the side here. So we have 36, and then negative 4 times positive 3 is negative 12, times the negative 1 becomes a positive 12. So that all goes to 48. So the discriminant is 48. Right? 36, a negative squared becomes positive, so 36. 4 times 3 is 12, that's negative, and then negative times negative becomes positive 12, and 36 plus 12 is 48. All of that over 2 times 3, which is 6. Okay, well, our 48 here is in a square root, so we want to find the perfect square in 48. Well, 48 will be the same thing as 24 times 2. None of those are perfect square. It would also be the same thing as 12 times 4, and 4 would be a perfect square, but we have a bigger one because 12 is also the same thing as, 48 is also the same thing as 16 times 3, and that's definitely the biggest perfect square that we have in 48. So we're going to say, okay, 48 is the same thing as 16 times 3. 16 comes out of the root as a 4, so this becomes x equals the 6 plus or minus square root of 16 is 4, and then the 3 has to stay in the square root, all of that over 6. Okay, so we simplified the root, we're done with that, but now when I'm looking at what I have here, I have a 6, a 4, and a 6. All of those still have a common factor of 2, so I'm going to divide them all by 2. So that becomes 3 plus or minus 2 square root of 3 all over 3. And that will be our final answer right there. All right. Here we have an equation with square root. So to solve an equation with a square root, we need to square both sides. So that becomes 25 is equal to, the square and the square root are inverse operation of each other, so they cancel each other out, and we are left with 4x minus 3. So now it's just a matter of two-step equation, right? So add 3 to both sides will give us a 28 equals 4x. Divide by 4 on both sides, that will give us a 7. So x equals 7. And if you're checking that, 4 times 7 is 28. 28 minus 3 is 25. And the square root of 25 is definitely 5. So that will be correct. Alright, so here, how do we do that? We have two square roots, but they're subtracted. Well, we can't square both sides because of that subtraction, but I can add, I can do plus the square root of 3x minus 5 to both sides here. So now we have square root of 2x minus 1 equals that square root, right? Because that will cancel. And now I can say, oh, okay, I have a square root equal to a square root. I could square both sides. Those will be inverse separation of each other. So I'm left with 2x minus 1 is equal to 3x minus 5. And now it's just a linear equation, right? So we're going to subtract 2x and add 5. So subtracting 2x from both sides and adding 5 to both sides. So 3 minus 2 is 1, so we're left with 1x, and then negative 1 plus 5 will be 4, so x equals 4. And when we're checking, 2 times 4 is 8, minus 1 would be 7, so that will be a square root of 7. And then 3 times 4 is 12, and then 12 minus 5 will be 7, that will be a square root of 7 also, so that will work. So this is actually a good solution. Alright, we have a quartic, and when we did the factoring video, we saw that those could be, when you have even powers only, those could be factored just like mimicking a quadratic. So what can I multiply to give me a 4, add up to give me a negative 5? Well, it could be negative 1 times negative 4. That would multiply to positive 4 and add up to negative 5. So I can replace my negative 5 with a negative 1 and a negative 4. I have to be careful though, because I started with a quartic, not a quadratic. So when I'm going to factor that, I'm going to say that's the same thing as x squared minus 1 and x squared minus 4, all of that equal to 0. And now the next thing I need to notice is that this is a difference of perfect square. That is also the difference of perfect square, so that can be broken into x plus 1, x minus 1, and x squared minus 4 can be factored again into x plus 2, x minus 2. All of that still equal to 0. Now I have only linear terms, and they're all multiplied, right? I have a multiplication here, here, here. And when I multiply them, I'll get a 0. So we use the zero product property to say x plus 1 equals 0, therefore x could be a negative 1. X minus 1 equals 0, therefore x could be a positive 1. X plus 2 equals 0, therefore x could be a negative 2. And x minus 2 could be 0, therefore x could be a positive 2. So we have 4 solutions. Negative 1, 1, negative 2, 2. And we expected 4 because we have a quartic, so that tells us how many solutions we are looking for, right? Alright. Absolute value equation. How do we solve those? So we have to remember that an absolute value is a distance away from 0. So whatever that is, it is 1 unit away from 0. So when I drop my absolute value, that means that if 0 is here, whatever that is, it is 1 unit away from 0. Well, it could be 1 unit away from 0 that direction, or 1 unit away from 0 that direction. So a unit away from 0, when we drop the absolute value, we have to realize it could be a negative 1 or a positive 1. So we drop the absolute value. We say that's the same thing as 3x plus 5 equals positive 1, or 3x plus 5 equals negative 1, because in both directions it will be 1 unit away from 0. And now we just solve it like a regular linear equation. So subtract 5 will be 3x equals negative 4, and then divide by 3. So x will be equal to negative 4 third. And then subtract 5 will be 3x equals negative 6, and then divide by 3, and x will be equal to negative 2. Now we have to check for extraneous solutions here because we have an absolute value. Just like when we have square root, we need to check for extraneous solution. An extraneous solution is a solution that happens as you're doing your algebraic step to solve the equation. But once you have it and you plug it back in your original problem, sometimes it doesn't give you a true statement, so you have to cancel that solution. Alright, so let's check. Negative 4 over 3. If I substitute that x by a negative 4 over 3, that 3 and that 3 will cancel, so I'll have a negative 4 plus 5 is 1. Absolute value of 1 is 1. So this is a good solution. I keep it. If I plug in a negative 2 here, I will get a negative 6. Negative 6 plus 5 will be a negative 1, and the absolute value of negative 1 is 1, so that's also a good solution, so I keep it. So both of those are good, no extraneous solution. Number 8. Number 8 says the absolute value of x minus 6 is equal to negative 1. Now, do remember that we said an absolute value is a distance away from 0. So that means I need to be at a distance of negative 1. Well, a distance cannot be negative 1, right? That's not possible. So this is a no solution case. Okay. All right, that's it for our review on solving equations. I hope that's enough of a mixture of problems for you to remember how those work.